Well, it's the end of October, and it's time to now start thinking about the upcoming winter here in the Willamette Valley. So it's time to upload my winter weather forecast for this year. This is the technical version, so I'm going to be going through my entire methodology and all the oscillations that I used, and most of the detail, the full detail, will be in the report attached in the description. If you just want the predictions, please click on the other video that has been uploaded at the same time as this. So, just as a disclaimer, this is a long-range forecast and is intended to provide a general sense of what may happen in the coming months. It is not a this is for sure happening, nor is it an excuse to not be prepared for a wind or snow or ice storm or any cold temperatures. Right, now that that's out of the way, I am going to go back over my 2022 to 23 scorecard with the things that have been updated since the recap video that I did in March. So the water year final total was 35.47 inches. And as a reminder, the water year runs from October 1st to September 30th of the following year. And the other change was the April 1st snow depth verified at about 115% across the Cascades, while the Mount Hood snow tell site was at 99%. So unfortunately, that does have to count as a half hit rather than a complete hit on the December forecast. Otherwise, I went over the rest of this during the recap video back in March. On to the methodology. I use an adjusted analog year approach using ENSO via the Oceanic Nino Index and confirming it using the Southern Oscillation Index. I also use both the Pacific and the Atlantic multi-decadal oscillations, and I also use the sunspout counts primarily to confirm which ENSO state we should be in or which one should be favored. And I do not weight the analogs equally, as analogs that are closer condition-wise to this year's conditions will have a higher weighting. In addition, I do make adjustments to the analog years if needed via statistical analysis. If there's a statistically likely or unlikely chance of something occurring, I will adjust the analogs unless if there's a clear trend in the analog showing the opposite. And general trends based off of the previous years will also be used when appropriate. I adjust snowfall prior to the 1970s to have a 4.3-inch average per winter on the analog years. I also adjust temperatures to each decade's average rather than the averages we are currently using today to counter climate trends and the urbanization of the Portland metro area, especially, though to a lesser degree, Eugene. And all forecasts will cover what has happened in 1 out of 3 winters at the Portland airport. So if I was purely guessing, I should get 1 out of 3 parameters correct in that case. So on to the data and the oscillations. This is the ENSO outlook for the United States models with some worldwide models put into here on the left. And it shows a strong El Nino appears to be likely for this coming winter, though some models are showing a moderate El Nino instead. The CFS forecast is also showing a weaker, strong El Nino. However, I do not know if I buy that it will dip next month. And for the world's look compiled by the Australian Bureau of Meteorology, the peak month looks to be January of 2024, where the world model average appears to be about 2.1 degrees Celsius warmer than normal, signifying a strong El Nino. Keep in mind that this is a 1-month average rather than the 3-month average that is used for the Oceanic Nino Index. That is the official definition of what is an El Nino or a La Nina. So the 3-month average is probably going to be a little bit less than that as a result. In March, it should taper off, but we're still firmly in the El Nino phase. So to comparing what happens during a moderate versus strong El Nino, both strengths of an El Nino, the snowfall chance doesn't look that good with about a coin flip of a chance of just seeing any measurable snowfall. There's a higher chance on moderate El Ninos versus strong El Ninos. The average temperature for moderate El Nino was near average, but a little bit above average, while a strong El Nino has had a strong correlation to above average temperatures. And also, I see no strong El Nino that has been below average more than 3/4 of a degree Fahrenheit for the entire winter. The median lowest temperature is 21 degrees for moderate El Nino and 22 for a strong El Nino, with 3 Arctic blasts happening between the two phases. The water year rainfall median for a moderate El Nino is 3 inches below the long-term median, while the strong El Nino was right at the long-term median. Up in the mountains, moderate El Ninos had okay mountain snowfall, but a strong El Nino had pretty bad mountain snowfall below the ski areas. But from the ski areas and above, it was a little bit more typical, though still slightly below average. For major windstorm chances, the further you go away from a completely neutral ENSO state, the less of a chance of a major windstorm would happen here in the Willamette Valley. So as we go into a moderate or strong La Nina or a moderate or strong El Nino, there's been no recorded major windstorms in all 4 of these states. So that makes me confident that we probably will not be seeing a major windstorm this year. Southern Oscillation Index the last 5 years shows that we are now in the negative phase, which does correlate to an El Nino state. However, we're not that strong into the negative phase, signifying that the atmosphere may be acting a little bit more like a moderate El Nino rather than a true strong El Nino like the ONI would suggest. The Pacific Decadal Oscillation the last 5 years shows that we are still deep into the negative phase. This made finding analog years a little bit difficult, as I have found no year with a strong El Nino via the ONI that has consistently been a negative PDO. It's either been and going back up to neutral by the end of the winter, or it was in the positive phase. And because I do not anticipate the PDO going back to neutral, well, it's going to be a one-of-a-kind winter in that case, atmospheric-wise. The Atlantic multidecadal oscillation in the last 5 years shows that we are still firmly in the positive phase. There's been no significant changes the last couple of years on that. Sunspot count, we're about 35% through the current solar cycle, signifying that we should be in an El Nino right now. So that's further verification on that. Now on to our analog years and the statistical analysis afterwards. So I chose 21 analog years to use that I thought condition-wise were pretty close to the upcoming winter. All these years, except for 1993 to 94, are El Nino years. They are also, if they've had consecutive El Ninos, the first El Nino in that series, because a first El Nino is important because the second one will not act the same as the first, and there's a lot of season to season correlations in that case, as you have seen with my previous forecasts in those statistics then. Top analog year comparisons. So 1919 to 1920 and 1951 to 52, while the El Nino strength was only moderate, the PDO was negative in both of these 2 years. These were the only 2 true ENSO years that, or El Nino years, that I have found that have had a strong negative PDO. The AMO for 1919 to 20 was in the negative phase, but 1951 to 52 was positive, and the sunspot progression on both of these showed that we should be favoring an El Nino. In both 1957 to 58 and 1965 to 66, both had a strong El Nino in terms of the ONI, but the PDO was more neutral in both of these years. The AMO was also both positive on these years, but they differ on the sunspot progression, where 1957 to 58 could really favor either way, but slightly tilts El Nino. 1965 to 66, however, favored a La Nina state. Also, as a side note, 1957 to 58 was coming off of 3 La Nina winters in a row, which is what we just experienced the previous 3 winters. 1993 to 94 is a unique case because the El Nino's strength in terms of the ONI was neutral, but it had a negative southern oscillation index as well, signifying that the atmosphere acted a little bit more like an El Nino state than the ONI would have suggested. Also, the PDO at the time was in the negative phase. While the AMO was negative, there was signs showing that it was starting to turn positive, which we have been primarily positive since 1995. The sunspot progression still shows that an El Nino was favored. Here are some extreme events that have occurred during these top analog years to kind of get a basis of what may happen this winter. So, December of 1919 is probably the most extreme month out of all these, where December 9th through 10th had 17.5 inches of snow in Portland, though there wasn't much snow down in the southern Willamette Valley. They did get snow later in the winter, though. It was followed by 3 days with lows in the single digits, and it was also the only time Eugene failed to hit 10 degrees or higher for their high temperature on December 13th, 1919. It was 9 degrees for a high temperature on that day. The other 2 months were pretty typical in comparison. 1951 to 52 was consistently, but not extremely cold in December and January, and had 9.6 inches of snow in Portland and just slightly less down in the southern Willamette Valley. Most of that occurred in January. 1957 to 58 didn't really feel like winter. There was no snow valley-wide, and it was 4.2 degrees above the decade's average, and this is the highest departure from average recorded at the Portland airport, though since I used downtown data prior to 1940, I did find a couple of years that had a higher departure from average back earlier. 1965 to 66 was another dud in Portland with only 0.6 of an inch of snow and no other significant events to speak of, though temperatures were near average. Eugene, however, had 7.7 inches of snow, 2/3 of which was in December. 1993 to 94 was the 3rd driest water year on record. In comparison, the rest of these analog years all had near or just slightly below average water years. And there was a valley-wide snowstorm in February, producing consistently 2 to 4 inches. So looking at the data for all the analog years in these blue circles and the top analog years in this bigger purple circle shows that while the all analog median is 0.7 of a degree Fahrenheit above average, after I weight the analogs, it actually tilts a little bit below average for this winter for average temperatures, showing 0.4 of a degree below average. For the water year precipitation, and slightly below average appears to be favored, with the weighted analog median being 32.41 inches, which is a little bit below the all analog median of 33.4 inches. The lowest wintertime temperature came out weighted to about 17 degrees, though I will note that this is skewed because of the 1919 to 20 coldest temperature after adjustment being 30 degrees. And all the other years were pretty consistently around the low to mid 20s in comparison. Adjusted snowfall, there's a lot of conflict in the analog years, with some years showing at least one significant snowstorm, while others, about 50%, are showing not much snow at all. The weighted analogs are showing 3.2 inches of snowfall. So with all this conflict, that is where the statistics come into play. So let's look at them. This first one, there's been 8 consecutive winters that have had measurable snowfall, and this is a record high in Portland. The chance of a 9th occurring is 5.3%, and this is unadjusted. Unfortunately, the way I adjust the snowfall is I adjust it just by year, and I do not remove any years that had snowfall to changing it to no snowfall. So that does increase the error of my forecast a little bit. So the chances really are probably a little bit lower than this. I'd estimate about 4.5%. There's been only 3 winters that have produced a temperature under 20 degrees with less than 1.5 inches of snow. All 3 of these years had 0 inches of snowfall. So that lowers the odds of an Arctic blast, assuming this statistic it turns out to be correct. Again, these are just based off of pure chance, though. 3 consecutive winters also have had 6 inches or more of measurable snowfall in Portland. The chance of a 4th occurring is only 2.5%, and this is also unadjusted, as I've not noticed a decrease in the amount of 6-inch winters here in Portland, as I showed in my statistics back in my February 22nd snowstorm recap video, where I went through some of these statistics as well in that video, though not the 8 consecutive winters in a row with measurable snowfall. 9 winters have had no major Arctic blast. I define this as having a temperature of negative 12 degrees Celsius at the 850 millibar pressure level over Salem. This air pressure typically occurs at about 5,000 feet, and if you descend an air parcel from this temperature or all the way to the surface under a completely dry environment, which will warm that air parcel up quicker than if it was 100% humidity or if there was clouds, that air parcel will remain below freezing through that entire air column. If you warm it up even just 1 degree Celsius at this level, it will no longer stay below freezing once it hits the surface. Chance of a 10th occurring is about 7.3%. Because this chance is higher than a chance of measurable snowfall, this is going to be overruled by the snow statistic. So let's get into the actual predictions. Let's start with the basics. For the water year, I'm predicting a near median water year with anywhere from about 31 to 39 inches here in Portland, because that's one of the drier spots in the Willamette Valley. That changing that to a percent of median, that's between 87 and 109% of the median. Winter, I'm predicting anywhere from 13 to 16.5 inches, a similar percentage of the median, with a best estimate of 34 inches. Temperature departure. Near normal temperatures are favored within about 1.5 degrees of average. My best estimate is right at the long-term average. Windstorms, I don't expect anything too crazy, though it will not be surprised if we see 2 or 3 windstorms this winter. I anticipate the peak gusts will be pretty close to our average peak gusts of about 50 miles per hour, so I'll predict between 45 and 55 miles per hour. Lowest winter temperature, I'm predicting above 20 degrees, with the best estimate being 22 degrees. Most likely to be active, I'm predicting that will be during the month of December. For the snowfall predictions, we'll start in the mountains. On April 1st, I'm predicting the snow depth will be in the higher elevations between 75 and 110% of normal, but in the lower elevations, I'm predicting between 60 and 100% of normal. I did find that on some of these El Nino years that there was a pretty consistent trend towards actual near normal snow depth on April 1st, signifying that with how negative the PDO is, that cancels the negative snowfall effects from the El Nino almost completely. Or at least there's a chance to at higher elevations. There's less of a correlation with that in the lower elevations. Now, for the valley snowfall. I'm predicting below normal snowfall in the Portland area with 0 to 3 inches as my margin of error. The best estimate, I'm saying a trace of snowfall. which if that were to verify, that would break the streak of measurable snowfall winters in Portland. In the central and southern Willamette Valley, I'm predicting normal snowfall with about 1 inch to 5 inches, and I do think that there is going to be a snowstorm in the central and southern Willamette Valley that completely misses Portland. 3 inches is my best estimate down there, with the chances of a snowstorm in Portland being on the screen now. The chance of a no-snow winter, I think, is a coin flip. As a side note, this is the prediction I am the most uncertain about out here. So that is it. So thank you for watching this. I will come out with an update sometime in hopefully early December, because I am predicting that December is the most active month. I am going to try to move up my December update compared to the around December 15th date that I've done previous years. So if I don't come out with a video before then, I will talk to you all then. And please stay safe out there and take care.